So this question wants to test for symmetry. Use the graph of the equation y equals x squared plus 2 to test for symmetry with respect to the x-axis and the y-axis and the origin. Support the answer numerically, then confirm it algebraically. Okay, first of all, I'm going to use the graph. This is the first thing to think. Is it symmetric about x-axis, y-axis, or origin? What do you think? Where is the mirror? Yes, so it should be the y-axis. Why? Because every point on the right of the y-axis has its reflection on the left of the y-axis, as we can see. And this is pretty easy for you to know. What about the rest? Support the answer numerically. How will we support it numerically? Yeah, we can make a small table, for example, x and y. And let's use numbers. Numerically means use numbers, right? So let's see some numbers at the right side. And for example, when x is equal to 1, y is equal to what? Y is equal to 3. But when x is equal to -1, y is equal to what? Y is also equal to 3, as you can see from the graph. Let's pick other points, for example. Let's say at 2, y is equal to, I think y is equal to 6. Okay, so what about the -2? Sorry, -2, the y is equal to 6 as well. And what we know from about symmetric about the y-axis is that every point x, y has the same point, which is -x and y. Is this true here? Every point x, y has the same point again on the other side, which is -x, y. And it's true over here. So yes, it is symmetric about the y-axis. What about confirm algebraically? To confirm algebraically that it's symmetric about the y-axis, replace the x, and remember that, replace the x's in the equation with -x. And see if it yields the same equation as the original one, then yes, it is symmetric about the y-axis. So we have many ways to confirm that it's symmetric about the y-axis, using the graph, or supporting numerically, or confirming algebraically. Is this equal to, I replaced every x that I saw, I didn't see except x squared, I replaced it with -x, only the x is here. Is it equal to x squared plus 2? Yes, of course it is equal, so that's how I will confirm it algebraically as well. So for this question, again, example 5b, it says use the graph of the equation xy equals -6 to test the symmetry with respect to x-axis, y-axis, and the origin. Support the answer numerically, then confirm it algebraically. So let's take a look at the graph. Is it symmetric about the y-axis? Is the y-axis the mirror? No. Is the x-axis the mirror? No. Then which one is this? Is it symmetric about the origin? If we rotate this graph 180 degrees, will we yield, or will we get the same graph again? Yes, because this will come up and this will come down. So it seems that from the graph, it is symmetric about the origin. What about numerically? Let's pick some numbers. For example, let's pick make a small table for numerically part, and let's think about x and y. Here is x and here is y, and let's see, for example, when x is equal to let's say when x is equal to 2, for example, when x is equal to 2, looks like y is equal to -3, right? Okay, let's check on the other side when x is equal to -2. Y is equal to what? When x is equal to -2, y is equal to 3. This is exactly what happens in a function which is symmetric about the origin. X becomes -x and y becomes -y. What do I mean? For every point x, y, the graph contains the same point but -x, -y. Not like the one that we just said symmetric about the y-axis. We said that the x changes signs. Here, both of them change signs. So for every point xy on the graph, there is a point negative x, negative y. If you want to support with more numbers, we can do that as well. Let's check, for example, 4. 4 looks like it's with negative 2, not negative 2. Looks, let's say it's a negative 1. 4, it's around more than negative 1. Let's say it's about negative 1.5. Okay, what about negative 4? What are you expecting for negative 4? Negative 4 is about 1.5. And the same thing happened again. Both x and y have opposite signs. So here I'm done with the numerically part. What about confirm it algebraically? Algebraically here, to confirm that it's symmetric about the origin, change the signs of both x and y. In the y, when we said about symmetric about the y-axis, we said change the sign of the x. And if it stays the same as the original function, then it's symmetric about the y-axis. The proof for the origin, symmetric about the origin, change both signs of negative x and negative y. And if I get the same as the original function, then yes, it is symmetric about the origin. And here when I multiply a negative by a negative, I'm gonna get xy equals negative 6, and so I got exactly the same as the first function or the original function. So yes, it is symmetric about the origin. Okay, here's a guided practice for you. Use the graph of the equation y equals negative x cubed to test for symmetry with respect to the x-axis, the y-axis, and the origin. Support your answer numerically. Maybe pause the audio and think a little bit. Is it symmetric about the x-axis? Is it symmetric about the y-axis? Or is it symmetric about the origin? If I rotate it 180 degrees, would I get the same graph or no? Yes, it's symmetric with respect to the origin. To confirm it again numerically, you can use numbers and prove that. For example, 1, here negative 1 has 1 as a y and 1 has negative 1 as a y. You can prove it algebraically by changing the signs of the y and the x and see if you will get the same equation or no. I hope I made it clear for you.